Hello again, everyone. I just took a bit of a short break there. So now, for the third in the series of recordings for you in the masterclass for Test 1, it's now the turn of Learning Unit 2. And there's two things in there. How we take a mixed cost and split it into its two separate components of a fixed and a variable cost. There's two methods that we can use there. One is the high-low method. The other is a linear least squares regression method. Okay. I'm going to be dealing with that in one particular question. And then the other main topic in the unit is learning curve theory. So I will then deal with that in the last installment in recording number 4. All right, so as usual, let me share a question with you. This one over here. Okay. I'm going to use this to show you how to use two different methods of finding the same thing. So we're going to first of all use a high-low method, and then in part 2, we're going to do it again, but using the least squares method. Both of these are going to tell me what's the fixed element of a cost and how much is the variable cost, either per unit or per activity. So let's see what's going on in this question. Always good to check out what the information is about. So this is a manufacturing business. They are making electric pipes. And obviously that is going to create a cost. So here we have the values of the cost, 4 different levels of output over a period of 6 months. So this total cost here at the end, this one includes fixed and variable. So what we want to do now is split it into its 2 component parts. Okay. So using the high-low method, we're going to take the equation for the cost function. And how does that one go? Okay, hopefully you've seen it before. It's y, let's make it a bit bigger, otherwise you can't actually see it, okay, is equal to A, which stands for your fixed cost, plus variable cost per unit times number of units. So what we want to be able to find in here is A, what's the value of A, and what is, where can we put it in? The pen doesn't like to draw. Nope, it doesn't like to do that. We're wanting to find B, because that will be your variable cost in this case per pipe. Okay. So what we're going to do here with the high-low method, as the name tells you, we're going to find the highest total cost and the highest matching number of units. And then we're going to do the same, but for the lowest. So let's be very careful here. Some students are just too much in a rush to get going with the question and make a silly mistake. So out of all of these costs here, which one is the highest? Here we can see it's 60,000 and the matching number of units is 3,000. Now let's look for the lowest. So the lowest is the one underneath, 45,000 units at, cost at a total of 1,500 units. Okay, so just to repeat, I made a bit of a mistake. Highest cost, 60,000. Lowest cost, 45,000 Rand. Highest level of activity, 3,000 units. Lowest level, 1,500. So now what we're going to do is follow the process in terms of which we always find B first. And B is going to be your variable cost per pipe. So that's looking at the change in cost as a result of a change in activity. And how we're going to calculate the cost change is by finding the difference between the high value and the low value, and the change in your activity is going to be the difference between and the high and the low value of the number of pipes. So let's do that. There. And when all is said and done, it's a very easy little calculation. We land up with 10 Rand per pipe. So please don't leave this as B equals 10. That means nothing. Okay. Only we understand it because we know the field of finance and we know what we're doing. But if you were to tell a manager or an employee or a colleague, B equals 10, they'll shrug their shoulders, roll their eyes and say, well, what's that? Okay. So it is 10 Rand per pipe is the variable cost. Now what we're going to do is, once we found that, step 2 is we're going to find A. And this requires that we take that cost equation and rewrite it, and we make A the subject of the formula. So it's going to go A is equal to Y minus BX. Now what do? We're going to substitute either both high values or both low values into that equation. So Y, remember, stands for total cost. It could be high. Then X is level of activity. It must be the high number of units. Or alternatively, we could use both low values. The only thing that you cannot do is use one of each, because that will get you a completely wrong answer. Right? So I've just decided here we're going to use the low values. You could just as easily use the high values. Okay? So what are we going to do here? We're just going to substitute in. A that we're trying to find is our fixed cost. So we're going to take our lowest value of Y, which is 45,000 Rand. We're going to take our lowest number of pipes, which is 1,500. And we're going to use that value that we just found there for B, because that is variable cost per pipe. If we do that, we're going to finish up with 30,000 Rand. And that will be your fixed cost, not per unit or anything like that. That will be your fixed cost in total. What happens if you rather wanted to use the high values? Let's actually do that then, should we? We can do that. So if we're going to use the high values, we are then going to say that A is equal to, what was our high cost? I think it was 60,000. And we're going to subtract your variable cost of 10,000 by 10,000 times what? The high units of 3,000, close bracket. If you do that, it's 60,000 less 30,000, which will also give us the same answer of 30,000. Do let your lecturer know which values you are using, in case you should make a mistake. Okay. So that's all there is to the high-low method. Super simple. Right, now, we're then going to do the same, but this time we're going to use a much more sophisticated, reliable, statistical method called the least squares method. I just need to make sure here, in this instance, that you don't get caught. Okay. You may or you may not get the formula. So please learn the equations that you would use to find A and B in the case of a regression. So what you need to do here is prepare yourself a table, and the table must contain all of the values that you're going to need for substitution purposes. So you obviously you would need X, and X is, in this case, units or activity. Okay. You're going to need Y, your dependent variable, which is your total cost. You will need N, and that's just the number of observations, which in this case is 6 because there's 6 months. You're going to make 2 new columns, in which case you have to do 2 calculations. You're going to take each value of X and square it. And then you're going to make a last column for X, Y, the product of X and Y. So in every month, you're going to take X and times it by Y. And then in each of the columns, you're going to have a total at the bottom. So you're going to have sum of X, sum of Y, sum of X squared, and sum of XY. Once you've got those values, and remember, you must do a table with all the values in because you get method marks and you get marks. Okay. Then you're going to take your equations and you're going to substitute in. There's a few ways that you can do this, and there are 2 sets of equations. Over here, you can use either of the 2 different formulas. Choice is yours. Okay. I prefer the ones that I'm using here because I found them easier to remember. But both formulas are in the book. The normal formulas are in the front of the book, but if you're looking for the alternatives, you can turn to the question bank at the back of the book, and you'll find it there in one of the questions. Yeah. So you can solve by doing simultaneous equations. Sometimes that goes a bit pear-shaped if your algebra is not good, because you need to move terms across. So I prefer to use a substitution method. So let me show you what I mean over here. All right, so just to make sure that everybody knows here, units is X, total cost, Y. So I'm going to copy those, add them up, and I'm going to get sum of X and sum of Y. That's very easy. You would only get half a mark each because you're copying the numbers from here. But you will get more marks for XY added together and X squareds added together. So pop all of that into a table. That's pretty straightforward. So I'm not going to really waste any time on that. Okay. So these are the values that we're looking for there. Sum of X, sum of Y, sum of X squared, and sum of XY. Now you see that can sometimes become very large numbers. Okay. So let's do the first of the formula. The sum of Y is equal to NA plus B times the sum of X. Okay. So all we're going to do is we're going to substitute. Sum of Y, we've got that over here in the second column, 315,000. Okay. What is N? It's the number of months. In this case is 6. A, we don't know. It's an unknown variable. That's why we just say A. Then we're going to need the sum of X, which is this, 13,500. And instead of making it look clumsy and saying B, 13,500, we just change the order. Then what are we going to do? Okay. Maybe you don't want to skip a step, but we're going to write it out in terms of A rather. So that would be 6A, going to move the A to the other side, is equal to 315,000 minus 13,500B. Then we're going to divide each term by 6 so that we write it out in terms of a single A. So don't forget that, everybody. You have to divide throughout by 6. Don't just divide the A, the 6A by 6. Every term must be divided by 6. Then what you could do is you could take this second formula over here. You could also write that out once you've substituted in terms of A. Then you're going to have 2 terms written in terms of A. And then you can do simultaneous equations. Or you're going to see, I'm going to do the substitution method. And I'm going to use that value that we found there for A. So first of all, let's get the equation. Sum of xy is equal to A times sum of x plus B times sum of x squared. Just a note on this term here. You don't take the sum of x, which is 13,500, and square that. Which one are you going to use? This one here. Because remember, we have a column for x squared. And we're going to add each value of x squared to get sum of x squared. So we're going to just pop the numbers in. Sum of xy is that number starting with 7. Then we're going to go this term over here. A times sum of x. And what I'm going to do here is this value that I've just got from above for A, I'm going to substitute that in. And then sum of x is the 13,500. So see that over there? This value is my substitution for A. Be very careful here that you can read your own handwriting clearly. Don't forget the letter B, because there's A and there's B's. You need to group like terms. So don't be careless and forget the B, or possibly think it's a 6 or a 0 or something. Then we're going to be all wrong. And then I'm going to substitute in plus B sum of x. Now what am I going to do? Basic algebra. I'm going to expand. So I'm going to take this lot here. Let me change the color so you can see it. I'm going to take 13,500 and I'm going to expand out there. So 13,500 times 52,500 minus 13,500 times negative 2250B. Don't forget the B. Right? Then you write on that last term. Now what do we see? We have got 2 terms that include B and 2 numbers. So we're going to group the numbers together and the B's together. So by rearranging to group them, we have to move to the other side. And how you do that is subtract. Okay. So we're going to find over here, I must take that, let me give you a different color. I must take this 708 number and move it to the other side by subtracting. What else must I do? So that's going to give me this number. Then I've got the B's. And what's going to be happening with the B's? They're on this side over here. Remember, there's a negative amount of B's and a positive amount of B's. So the positive value exceeds the negative value. That's why B is positive. And also because we've moved the numbers to the other side, we must have, this is terribly important, everyone here. If you don't get this, it tells you you've made a mistake. So you must have both values positive or both values negative. If you have one of each, it means your math has failed you. And then you're going to see we have a lot of B's. So how do we get rid of that? Okay, we're going to divide throughout by the 1375000. Divide both sides by that, and we're going to get an answer of B is equal to 10, which you will see is the same value that we got in the high-low method. Now, what are we going to do? To find the value of A, we need to substitute. How? By using that equation over there. So that's why I like this method. It's slightly quicker. Okay. So we're going to take this value here of 10 that we found for B, substitute in there, solve, and get A. And it comes out to be 30,000. No surprise. So we're going to conclude by answering the question. So we can't say B is 10, A is 30,000. We're going to say variable cost is 10 Rand per pipe and fixed cost, prefer to write it in, fixed cost in total is 30,000 Rand. Okay. There's just one other little thing I want to add in here. Okay. We have found the values of A and B. So we can then write up the cost equation, and then we can use the cost equation to estimate the total cost for any given number of units. So if we have a look here at the values provided, let's pick a different one. Let's say that the number of pipes is 2,250. If we want to estimate the total cost of that, yes, of course we can do it by using our cost equation. So let's type it up in the correct format. We're going to say Y is the dependent variable. That's going to be my total cost, is A, which we said was 30,000, plus B, which we said was 10. Then we can substitute in any value for X. For example, 2,250 pipes. And then we can go and we can solve that. So what would that be? That would then give us Y is equal to the 30,000. And we're going to go and add a further amount of 22,500. And that then will give us a total of 30 plus 22.5 is 52,500 Rand. So that shows us the practical application of a theory. So once we have found the fixed and variable portions of an overhead cost, we can then write up the cost equation, and we can use it to find the total cost of any given level of activity. So, right, that was a nice section. Hope you enjoyed it and hope you understood it. That's the main thing. Right, so I'm going to wrap up this one, and then there's going to be one more recording, and that is going to be on the learning curve theory, also in Learning Unit 2. So thanks everybody for your very important and scarce time. Hope you've learned something from it.